The last ALEKS problem that you have to solve is preparing a strong base solution with a given pH. So let's take a look at that one as well. For this problem, it says that we are trying to make a solution that has a pH of 13. We want 700 milliliters of that solution, and we want to use sodium hydroxide, NaOH. And it's asking us to calculate the mass of sodium hydroxide that you need for that solution. It's also giving us a lot of information that we don't need to solve this problem, so we're going to ignore it. And let me tell you, that is really satisfying to black out part of an ALEKS problem. So this is very similar, almost identical to a problem that that we did in our notes. We know we want the pH of the solution to be 13. So that tells us, we can use that information, pH negative log of H3O plus. We can use the pH of 13 to help us figure out what type of H3O plus concentration we need. However, we are working with sodium hydroxide, NaOH, so again, it's more useful for us if we deal in terms of pOH instead of pH. So if we need a solution that has a pH of 13, that means we need a solution that has a pOH of 1. pH plus pOH equals 14. We can use the equation OH minus is equal to 10 to the negative pOH. For this problem, it's 10 to the negative 1, which is 0.1 molar OH minus. That's the solution that we need. So we know that we need to have 0.1 moles of OH minus for every liter of this solution. We also know from the problem that we're trying to make 750 milliliters, or 0.75 liters. So that's going to tell us how many moles of OH minus we need. 0.075 moles. And if we look at the formula for NaOH, there is one OH unit in every one NaOH molecule. So OH and NaOH are 1 to 1. So that means that if we need 0.075 moles of OH minus, we can figure out 1 to 1 ratio, 1 mole of NaOH for every 1 mole of OH minus. And now all we need is the molecular weight. 23 plus 1 plus 16, 40 grams of NaOH per mole of NaOH. We need 3 grams. It worked out to a really nice number, so that makes me feel kind of nervous. I might have messed my math up somewhere, but the process is correct.